Greetings. I hope this message finds you well. I have disturbing news. The dark side is close. The only answer is more science. And welcome to Mr. Wood's Kitchen of Science. We're going to do some experiments this week, and I'm going to just show you how they're done so that you have a video copy so you can go back and check out. I've got some special assistants helping me out today, Charlotte and Henry. We're going to enjoy the very first one. So you don't have to do all of these experiments if you don't have the right materials. You don't have to do any of the experiments, or you could do all of them. So whatever you're into, go for it. I love to see what kind of results you get. So if you can do it, make sure that you put your video up on Flipgrid. And I mentioned in the Flipgrid document that sometimes it's easier to actually film it on your iPad or your camera before you actually put it into Flipgrid rather than record it in Flipgrid. And the reason is then you can kind of go back and edit it after. But whatever floats your boat. So today we're going to talk about the states of matter. The states of matter. So not like the United States of matter, but like the state it's in. So there's three common states of matter that we see around us. They are, what's this table? Solid, liquid, or gas?
Solid.
Solid, yeah, you can put your hand through it, right? What would milk be?
Liquid.
Liquid. And when I pass gas out of my rear end, what is that? It's a gas. Yeah, gas. I told you I pass gas out of my rear end. It's called fart. Those are the three states of matter. There's actually 7 states of matter if you want to get scientific about it. You won't learn about those unless you study something called fluid dynamics as you get into university. But plasma is a common one that we can actually manipulate on Earth. And you would see that if you took a nice trip to the sun. So the sun is actually producing plasma under a tremendous amount of heat and pressure. Lightning bolts also, depending on how hot they get, can actually produce plasma as well. It almost looks like fire, which is kind of cool. So today we're studying it, and what I want you to do is you explain what is happening at the molecular level. What's happening to the molecules as we go through the states of matter. So I'm guessing that things are solid, and they're solid because those molecules that make up this table or the chair you're sitting on are very tightly packed together and moving very slow. Because if they were far apart and moving quickly, I'd fall right through them and likely burn my rear end. So it's important to understand what's happening to the molecules. And we're going to talk about that in class, but I want you to start to think about it as we do this experiment. So this is a really fun experiment. You need a few things. You need some Ziploc bags, 2 of them. You need a container with a lid, preferably see-through. You don't really need to, but it helps. So we've got some Tupperware, and make sure the lid is secure. You're going to need some candy. So we've got some jujubes here, and we've got some chocolate chips. And finally, you're going to need some warm water. So we've got some warm water here. It's been boiling. Please be very careful with this. You don't need to use boiling water. It just speeds up the effect. You can use warm, as hot as the tap goes as well. It just takes a little bit longer. So if you need your parents' help with that, go for it. So what are we going to do? We are going to figure out how fast these candies can change state and what's happening as they change state. So think of the molecules as they're doing it. So what are we going to do? Pretty easy. You're going to take your chocolate chips. We're going to open the bag. Should have done this before. And you're going to take about 10 chocolate chips. So I'll put our little tray out here and grab yourself 10 and put them into your bag. And you're going to do the exact same, but because these are bigger, we're going to go with 5 jujubes. And 5 jujubes is good because they're bigger. And let's make sure that we get the black ones because, goodness, nobody wants to eat those things. Let's use them for science so we can eat the rest. Yeah. And there we go. So grab 5 jujubes. just hand picking the dark ones. And put them in a separate bag. So if I had my bag, I would be adding them in here. I'll grab 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Goes in here. Boing. That's it. Hard, I know. And you have 5, so put them inside your bag. Assistance. Do you need help opening them? Good. All right, so we will move these ones aside. And when they're in your bag, you can tell they're solid, right? You can move them around. You can put a little pressure on the chocolate chip. If you really wanted to and you're strong enough, you could crush it, but it's difficult. It takes some energy. And the same with the jubes. The jubes themselves are in a solid form, but they're squishy, which is interesting. They're interesting because they're squishy. So when you put them in, they're still a solid. And we define solids and liquids by the shape that they take when they put in a container. So when you pour milk, it takes the shape of the cup. If you put water in your bathtub, it takes the shape of the bathtub. And that's because the molecules aren't as stuck together as they are in a solid. Sorry, you got 5. It's good enough. Okay. And you got your chocolate chips in your bag yet? Nope. Use these ones. There you go. And we'll do another bag here as like, we'll call this the, put those in here. We'll call this the placebo here to see if it will work. So you're gonna take your container now and take your lid off. So Henry, take your lid off that one. And what you're gonna do is we're going to put the bags in so that the chocolate chips are at the bottom, and they're at the bottom. And it's okay if squish it down. Just make sure that they're at the bottom. And what we're doing is we're gonna add some heat to it. So we're taking hot water, boiling water, and we are going to pour it on top of the bags and close the lid. So we're gonna trap that heat in there and see what happens. And so I want you to take a second now, pause the video, and then think about what it is that's happening at the molecular level, okay? So you do need a lid. Did your lid fall? Grab your lid, perfect. And what I'm gonna do is before you put it on, we're gonna put some hot water in it. And be very careful here at this stage, because as you can see, it spills out everywhere. And what you're gonna do is quickly, going to put that lid on. And the container, if you're using plastic, is obviously going to be very hot. So try not to touch it, which is why I suggest an open, clear container so that you can see what's happening. And we'll fill this up. And it's interesting too, if you have enough chocolate chips, you want to do multiple ones of changing the size of the container to see the result. And we're gonna let those sit for a minute. But while we're doing that, I'm gonna ask you, what do you think is going to happen? What do you think is gonna happen to the chocolate chips?
Oh, they're gonna melt.
You think they're gonna melt? What do you think they're gonna look like?
Chocolate, like chocolate milk.
Like chocolate milk, that's a good hypothesis. They're gonna change to a liquid, right? And they'll take that shape of however the bag is sitting there. What about the jubes? Do you think they're gonna do anything different? Or do you think they're gonna melt too? Because it's pretty hot in there.
Yeah, I think they're gonna melt.
They're gonna turn into a liquid as well. So we're going to leave those for a minute. We're gonna move on to another experiment. So this one I didn't put on your list of ingredients because not a lot of people have it at home. If you do, go good. If you don't worry. But it's Alka-Seltzer. So I used this in my Earth Day video if you watched it. And what we're gonna do is we're gonna show you a change of state. Really easy. This one is interesting though, because this one is going from a solid, and we're gonna turn this into a gas. So we're the solid here, it's solid, and then we're gonna turn it into a gas. So how do we do that? Cast a magic spell, talk to it. What do we do?
Drop it in water.
Drop it in water, right. Drop it in water. So we've got a couple old pop bottles here and clean them out. And what we're gonna do is we're going to put some water in it. And since we've got the hot water here, we're gonna pour it in. So I'm gonna be very careful as I pour it in. You don't need hot water for this. It just happens to be close. And you don't need a ton of water, as you can see. I fill it about a third of the way full, maybe a little more. And it's kind of cool because it collapses due to the heat, which is why I like to use hot water for this. Oops. And this is also going to help us answer the question of why it is we think toys are made out of plastic. So the bottle itself is hot. Now, it won't fit in. So we're going to use a knife, or you can use your hands. I'm using a knife. Please be very careful as you do it. And what I'm going to do is just cut it in half. So these things are notoriously not easy to cut. So be very careful, but you can just break it. Now, the question is, I've got two separate pieces. Is this still a solid, or is it a different state now?
It's a solid.
It's solid still, yeah. If I took a piece of paper and it showed it to you, you'd say, oh, Mr. Wood, that's a solid. And then if I ripped it up into a bazillion pieces, it would still be a solid because it's still paper, just a smaller form of it. And we'll learn a little bit more about that as we study chemical reactions. The other part of this one is a balloon. So you need a balloon, which was on your list. So again, it works the best if you don't have it, but what you're gonna need to do is put it onto the lid very quickly as it goes in. So I'm gonna get my one assistant. Henry, you drop them in and I'll put the green balloon for you. One, drop this one in quick. Gotta be quick like a bunny. And what we're gonna do is put this on. And we're gonna watch carefully through the see-through bottle what's happening. Where did that tablet go? Is it still a solid?
No.
No, it like totally disappeared. Now, it didn't fill the balloon up. The balloon isn't going to pop by any stretch of the imagination, but the solid's gone. So it could have two things could have happened. It could have dissolved into the liquid and became part of the liquid like you would see with sugar or salt, but by adding the balloon, it's telling us something that happened. So this balloon is full, way more full than it was when we put it on. What do you think happened to that pill? That tablet?
It turned into gas.
It turned into a gas. You're absolutely right. And that tells us not a lot. You wouldn't want to eat these things and then be burping up for an hour because it's turning so much gas, but it's designed to help ease your stomach if you're having an upset stomach. So that's pretty cool. All right. You want to try? Who's next? Where's the Alka-Seltzer? There we go. And we'll open this one up and try this. We'll cut it again. Being very careful. There we go. This will cut a little easier, but we've got some two pieces. So Charlotte, you pop those in, and I will get the lid on. The balloon on as quickly as I can. Boing, boing, and boing. Capture it. All right, there we go. So again, we're watching. I don't know if you can see, but the tablet disappears very quickly, but the foamy things are actually gas. And you can look closely at the sides, it's bubbles, and those bubbles are gas. So the tablet actually turned from a solid directly to a gas. So we would call that sublimation. And sublimation is actually more common than you think. It happens in the cold winter. If you look outside after it snows and the snow's been there for a while, even though it's not hot enough to melt, you'll see the snow start to disappear. It actually turns right into a gas. And sometimes you can see it if you have a place where the sunlight is directly hitting the snow on a cold day, you'll see steam rising, which appears to be steam, but it's actually the snow going directly into a gas, which is very cool. Okay, while we leave these over here, we will go back to our containers and check on them. So they've been in here for what, a few minutes?
Yeah.
So we're gonna carefully take the lid off. I will do this because it is hot. Here. And what we're gonna do is we're not gonna reach our hand in there because that water is very hot still, very, very hot. And we're going to carefully pull the top out, which will be the coolest part, and take a look. Again, here, and we'll just get this water out of the way. And then same with you. Carefully, it has cooled down significantly. It's not gonna burn you, it's just gonna be an ouchie. And then there we go. So what you wanna do is you wanna grab your things and squish them now. See how easy they squish? Show the camera as you're doing it.
Oh.
Squish them up.
The black ones didn't really.
The black ones didn't do it very well, did they? But I can squish them so easy now. So squish them up. Is it hot? The bag really hot?
Yeah.
It's not too bad, but you wouldn't want to.
Burn your hand.
Yeah, I wouldn't want to put it on my face. Okay, so look at as it squishes up. Now this one here, you can see. The question I have is, did we change the state? Did this melt? Did it go to a liquid from a solid? I think so. That looks pretty liquidy to me, doesn't it? What about this one? See, even though it's squishy, I think the pieces are still very much solid.
Yeah.
So it almost looks like it could be like in between Jello and the candy still. So it depends how hot it gets, right? Most everything has a melting point. Rocks have melting points, obviously, from volcanoes. So it just depends how hot you can get that. And I think we've changed it almost into a liquid. We've definitely melted the chocolate chips. We've all had that experience before. So hold your bag up, Henry, to see. Not bad. It turned into some chunks as well. So very cool. All right, we are going to sign off, clean this mess up, and then come back for a third experiment. Thank you very much, assistants. Okay, welcome back. Now we're going to move on to one of the best, most funnest, what I think, chemistry experiments you can do. Totally safe and absolutely interesting because we're going to use a story from Dr. Seuss called Bartholomew and the Oobleck to figure out which state oobleck actually is. And so it's really easy to do this. You need some cornstarch. Cornstarch comes in containers and boxes. You need about 2 cups. So we have a measuring cup here. It doesn't have to be right on, but as closest to 2 cups as you can get. You can use a bowl for this, but it's more fun to use a tray in my opinion, but a bowl would just work just fine. The reason is because you want it a nice thin layer of it so you can squeeze it and interact with it. So what we're going to do is we're going to put our cornstarch onto the plate carefully. Get it all off. It's pretty sticky stuff. And then we'll fill it up with some more here. And you can see that basically an entire container is used up for 2 doses of this stuff. So we'll be careful again here. Pour it. And we'll try and get it off. Okay, the trick with this is not to overdo it with the water. That's the real trick. Because if you put too much water in, it will not work. And what's really interesting about oobleck is it can be a liquid and a solid at the same time. All with this interesting stuff called cornstarch. So let's talk a little bit about cornstarch. If you look at the ingredients on a cornstarch, it actually has 1 ingredient. Do you know what the ingredient is?
What?
Cornstarch.
Why?
Cornstarch is an ingredient. So how you make it is you take corn, imagine that, surprise, right? And then you mill it, or you grind it up until it becomes this fine itty bitty powder. So it's totally natural, which is kind of funny because it is so cool. So now we're going to add 1 cup of water. So we've added 2 to 1 the ratio. So say you don't have 2 cups, you have 1 cup, then you would add how much? 2 to 1, so you'd add half a cup. All right, so what you want to do is, again, it's always better to start with less water, just in case, and you can always add more. So you want to make sure your sleeves are rolled up, guys, before you do this, because it will get messy. This is a definitely messy experiment. If your parents don't like mess, just tell them to leave the room for 20 minutes. Okay, here we go. So I use warm water. Again, warm water is moving a little quicker on the molecular level, so it'll speed up the process. Not necessary. I just use tap water, actually. So I'll put in just shy of a cup here. And here we go. and I'm gonna pour it on it. And so your job, assistants, you have the hardest job, is you are going to mix it up. Now, to add some fun to it, I like to add a little food coloring. So do you have a preference as to which color you want?
Blue.
We have blue, yellow, red, and pink, or purple, or whatever it is.
Blue.
So blue. Okay, so we'll get those ready.
Blue.
So I'm going to add this, all right? And I want you to start to mix it up. Henry, you get your hands in there and start mixing it up. Don't be shy. And I'll add a couple drops. No, like you gotta mix it up. Like just, yeah. Keep going. Try to keep it in the tray. Okay, I'll put a couple drops around here, but get the water to mix in with it. It's gonna take some effort. I'll help you, but I just wanna get this done for Charlotte so she can start. So Charlotte, it appeared to have like just shy of 2 cups. So I'm actually gonna add just shy of 1 cup. Again, keep the water on the low side until you're certain you wanted this one. Okay, start mixing away. So what you want to do is you want to actually get in there. Like, don't be shy. See that?
It's so hot.
It's nice and warm, yeah. So mix and mix. And the cool thing is if you get it wet and you squeeze it and let go, it actually turns into a liquid. It is the coolest effect, but you gotta mix it up a little bit better. So Henry, keep mixing, but keep getting it. You gotta scrape with your hands. Try and keep it in the tray. It's tricky, I know. And get it all mixed up. You shouldn't have any powder on there.
There's blue in mine.
Some blue, I think it dripped. Okay. Good, you got some liquid water here. Now, like I said, this is not a clean experiment, but any real good science isn't clean. So if you take it here, good, and you keep mixing. Good, it looks like we probably need a little bit more water, so I'm gonna just add a little bit more, but not very much. Like I said, we don't want to overdo it here. Okay. It will not work if you don't do it properly. So just work it in as best as you can. If it's sticky like that, it's good. It's smelly though, isn't it? It smells like a farm because it's corn.
Ew, it smells like horse poop.
So if you watch, I grab it and it's a chunk, and then I let go and it turns into a ball. So I squeeze that, squeeze, and then I let go and it melts right before my hands.
What?
And my eyes. Why is it doing that? So your job isn't just to muck around with this. It is also to figure out scientifically what is happening. What is happening to the molecules? How on earth can diced up corn change from a solid to a liquid before our eyes? And I can give you a bit of a hint. It's something to do with the action of squeezing it. So what does squeezing it have to do with it? It is so cool like that. Melts. And then melts away. Fun.
Oh my gosh.
So much fun. Okay.
It's like hard.
We want to see your videos of all these experiments, so be sure to put them on Flipgrid. And don't forget to check out the Google slide presentation on Classroom. And we'll be discussing this all this week. The changes of state in matter. Thank you so much for watching. Bye-bye.
Bye-bye.
Okay, can you stop it? The video is... I can't touch it now.